Hello all. In this class, you will understand what is meant by dependency graph and order of evaluation of a parse tree. A dependency graph is nothing but a graphical representation of a syntax tree with the notation called solid line with directions. How the values are moving in that direction, you have to write the direction of an edge with the solid line. Therefore, the syntax tree will not be in the solid line now, because in the previous video and all, for annotated parse tree we were writing solid line for the syntax tree. So that need to be modified now. With the dashed line, we have to first write the syntax tree or parse tree, annotate them, then you have to complete it by introducing a solid line with the along with the direction. What is the dependency graph? So let us understand what is meant by dependency between the nodes. If there is a production of the form x produce y z, and we are making use of a value of y and z to produce the value of x. So since you are using value of these two are children of x, and since these values are used for computation of x, we call that as a synthesized attribute. Therefore, x is attribute here depends on these two values. So you have to write the direction in that way. From here to here you have to write the solid line. So let us take this production, e produce e plus e, and the semantic rules already we know that. Write that in the tree format. So for writing the tree format, as I said, it is a dashed line. Once that is done, you have to write which node dependent on which value, which node. This node is dependent on these two values, therefore write the dependency. Okay, so this is the node which is having dependency on e1 and e2, therefore you have to write the solid line along with dashed line. So parse tree will be in dotted or dashed lines. Order of evaluation of this tree is, I need to compute this value with the help of e1 and e2. Therefore 1, 2 and 3, that is the order you have to write. Or else I can also compute 2 value first, then 1 value. That doesn't make any difference, because for the computation of this I need both the values. Okay, so therefore you can also call it as 2, 1, 3 as a order of evaluation. So we will do the example. Previous video you can just watch it, where we had constructed this tree. For the string 3 star 5, 3 star 5 is our input string. We had already constructed in the previous problem parse tree. So same thing we are writing here in the dashed or dotted line parse tree. Then this annotations were also done. All these annotations are already explained. Only you have to look into this order of evaluation here. So I need a 3 value to be computed first, so I label it as 1, and this value is moved here 2. Okay, after this I need this value, therefore first fetch the value from this 3, then I will call this as 5. After doing this, 4. So after this, for this operator I need these 2 values, so I have to borrow from this, therefore I will label it as 5. So this labeling you can do according to your wish. So afterwards, while writing the topological order or order of evaluation, in what way, which value to be computed first, you have to write it in the order. Okay, 5 is coming here, so it is 6, and this value is also coming here for computation of this value. So 5 star 4 has been computed and called as 6. Then because of the epsilon, this value has been converted into synthesized, therefore 7, and this value is moved up, so 8, 15, then this value is again moved to the root, that is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, This is the order. Or you can also write, I will create this first, I will create this next, then I create this, and I borrow this for computation of this, and so on. Therefore you can write 1 first, 3 next, then 2, then 4, then same order. So this is what order of evaluation. And the dependency graph. Dependency graph, you can see here solid line, which value dependent on this. So this value has been dependent by the sibling, write that direction. So similarly this is dependent, and this is dependent on inherited value. Then this value is moved up, so it is dependent, and this is also dependent, solid lines. And this value has been moved down for computation, and this is also taken from left, it is a solid line. So you have to write all this value moving in which direction, same direction you have to write the direction of the edge with the solid line. That is called a dependency graph. So this is example of dependency graph as well as order of evaluation. Thank you.